Okay, good evening, my dear students. Welcome to Gradeup, India's biggest e-learning platform. So I welcome you all to this live session of the VIZAG MT 2020. Yes, very good evening, all of you. Let us wait for a while so that you guys can join me to this live session, and I welcome all the aspirants of VIZAG Management Trainees 2020 to this Gradeup dedicated platform for the GATE aspirants. In this channel, we'll be discussing all the questions related to the GATEs, and we'll be having the live lectures also related to different PSUs and also different yes, Sai Gopal, yes, I know, I got an update in the afternoon. The exam has been postponed. Fine. So we'll be continuing this series. So today we'll be having a class on the heat transfer. We'll be having the rest series 1 week before the examination, because as you all know, VIZAG Management Trainee 2020 exam has been postponed. No, it's not cancelled, it's being postponed. So what you can do, you will be waiting for, like, for example, definitely they'll be giving the dates 1 or 2 weeks before. Okay, fine. So don't worry about that. We'll be having this session, and the remaining sessions will be postponed according to the dates which will be confirmed by the VIZAG team. Okay, so don't worry about that. It's not cancelled, it has been postponed till further notice. Clear? Yes, I know. Ajay, Subhash, good evening. Rahul, Subhash, Rashad, yes, VIZAG has postponed, and in the afternoon, I hope so, all the aspirants in the afternoon, they might have got a text message from the VIZAG Steel team. So your exam has been postponed. So don't worry, we'll be having a discussion in today's session, and also we'll be having some doubts clearing session also. Okay. And the rest of the session, like, we were having a complete series of the session for the different subjects. So from tomorrow onwards, you won't be having any VIZAG Management Trainee 2020 classes. Instead, what you can do, you can still prepare for SSC JE, because SSC JE, there is no update about the any postpone or cancellation. So definitely you need to prepare for this examination in a new Gradeup channel of SSC JE. Okay, good evening, Pramod Deva. What about CHSL? I don't know about any update, because still official update has not been announced from CHSL. So don't worry, but VIZAG Steel have updated the exam has been postponed. Okay. So very good evening all of you to this live session. So we'll be having discussion, because whenever you are getting any time for having discussion of any topic, definitely you should be doing. It will never ever going to be waste. Okay. So let us start. All of you know about my, let me introduce myself. My name is Sooraj Gopi. I have 5+ years of teaching experience. This is my area of expertise. I have teach mainly mechanics, heat transfer, theory of machines, and industrial engineering. Fine. And thermal applied also. So this is my area of expertise. And I again welcome you all to this live session on the GATE Gradeup platform. Okay. Very good evening all of you. So let us start the rapid question session of heat transfer. That will definitely help you out in SSC JE also. So don't worry, whenever you're getting time for solving any problem, definitely you should solve the problem. So let us start the session with the first question of the day. Now this question is from your conduction topic. Good evening, Rishabh. So let us start the session. I want you all to please solve quickly, because in VIZAG Steel, they are basically asking a very easier question. 1 mark question they are asking. Either what you can do, you can go for previous year GATE 1 mark problem. Fine, because the level is that much only, because calculators are not allowed. So ultimately you will be getting a very easier direct formula based problem. So let us start with the today's session. The first question of the day: an aluminum sheet of 10 mm thickness is brought into contact with iron sheet of 20 mm thickness. The outer surface of aluminium is kept at 100 degrees Celsius, whereas the outer surface of iron is maintained at 0 degrees Celsius. If the ratio of thermal conductivity, that means K of aluminium to the K of iron, the ratio has been given, it is 3:1. You have to tell me what is the interface temperature. Quickly tell me. Quickly solve it. Durga Prasad, good evening. Good evening, Rishabh. Please try to solve this problem, because I know VIZAG Steel has postponed, they have not cancelled. So don't stop your preparation. You need to be in touch with all the subjects. Okay. And also from tomorrow onwards, we'll be also postponing the VIZAG Steel series because it was dedicatedly for 1 week before the examination. Okay, so don't worry, we'll be again resuming back whenever the notification will be coming. Fine. So we'll be having the session again. So let us solve this question. Ajay Yadav, I got one answer from Ajay. Anyone else who has solved this problem? Rahul, Rashad, please quickly solve it. Very basic. Let me help you out. It's basically we are having two different materials. This is having one is aluminium and another is iron. And aluminium is kept at 100 degrees Celsius and iron is kept at 0 degrees Celsius. The thickness of aluminium is 10 mm. This is 10 mm. And the thickness of iron is 20 mm. You have to tell me what is the temperature at the interface T. Very good evening, Akash. Yes, very good. I got one correct answer from Anil. Anil Akhil, your answer is correct. Ajay Jadhav, please check your answer. Pramod, yes, correct. Rashad KP, your answer is correct. Very good. Satyakant Mishra, very good. After long days, I am seeing Satyakant. Answer is correct. So how to solve it? Very basic. It's in series, so same heat will be flowing. So directly you can apply Fourier's law of heat conduction. So it will be minus K of aluminium cross section area into 100 minus T upon the thickness. Let us assume I'm taking in mm. So for that your calculation will be very easy. Is equal to minus K of not minus, it will be plus because I have already taken K of iron into cross section area into T minus 0 upon 20. Fine. Yes, what is your answer? Ajay Yadav, yes, now you are correct. Answer is correct. David Raju, Avinash Bhatt, exactly correct. Cross section area will be cancelled. So you can directly cancel out cross section area. So it will be K of aluminium upon 1 into 100 minus T is equal to K of iron T minus 0. It will be T into 2. Okay. Now the ratio of aluminium is to iron is 3:1. You can directly substitute this as 3:1 and you will be getting 600 minus 6T is equal to 10. So it will be T is equal to 600 by 7. That will be 85.7 degrees Celsius. So option D is the correct answer. Option D. Yes, very good, Durga Prasad. Correct. Very good, Dharma Teja. Rahul. Yes, your answer is correct. Option D is the correct answer. And the level of question which they are asking in your any PSUs, if they are asking the question from the heat transfer, if I've taken up the previous years, they are basically asking from conduction, from critical radius of insulation and shape factor. These three are the favorite topics for if I are taking the previous year VIZAG steel paper or any PSU paper from the heat transfer. These three are the topics because these three are very easier questions. One mark question we can directly ask. So let us go to the next question. Now I've taken some more number of questions from the critical radius of insulation. So let us try this question. A 10 mm diameter electrical conductor covered by an insulation of 2 mm thickness. The conductivity of insulation surface is 0.08 watt per meter Kelvin. The convection coefficient of at the insulation surface is 10 watt per meter square Kelvin. Addition of further insulation of the same material will. Yes, tell me, what is the correct answer? Is it option A, increase heat loss continuously, or option B, decrease heat loss continuously, or option C, increase heat loss to the maximum value, then decrease heat loss, and option D, decrease heat loss to the minimum value, then increase heat loss? Just remember, those who have studied from me, they might, I've told you in every class there is a graph, region 1, region 2, your heat transfer reach to the maximum heat flux, then it decreases. Fine. So the maximum heat flux is corresponding to the critical radius of insulation. Okay. Yes, quickly tell me. I got one answer from Satyakant. Very good, your answer is correct. Ajay Jadhav, correct. Rahul, correct. Rashad KP, correct. Very good. Exactly. The critical radius is Exactly, it is coming out to be 8 mm. If the critical rate is coming out to be 8 mm, what is the radius? Radius of this wire is it is 10 mm diameter, that is 5 mm is the radius of the wire. Okay, now let us calculate what is the critical radius of insulation. This is K by H. What is the K value? K value is 0.08. So it is 0.08 by H. H is 10. So it is coming out to be 8 mm. Because this is in meters, so it's basically 8 mm. Now, your radius of the wire is 5 mm and the critical radius of insulation is 8 mm. So, if you add 2 mm insulation, what will happen? If you add 2 mm insulation for this, then your new radius is coming out to be 7 mm. Fine. So, remember the graph of heat flux with radius. It basically increases to the maximum value, then it decreases. This maximum value is corresponding to RC. Now, your RC is basically 8 mm and your new critical radius is 7 mm. So, basically we are lying in this region 1 where added insulation will increase the heat transfer. But after more insulation, what will happen? It will reduce over here. So, basically option C, increase heat loss to the maximum, then your decrease heat loss. Very good, all of you. Those who responded, option C is the correct answer. Any doubt? Because in VIZAG Steel, they are basically asking the questions from critical radius of insulation frequently. Okay, very good, Satish. Your answer is correct. And I'm again repeating, VIZAG Steel has postponed their paper. They have not cancelled. So please be sure you are ready with your concepts, you're ready with your preparations. So try to solve as many questions as you can in this live session. Okay, very good, all of you. Option C is correct. Let us move to the next question. A pipe of 25 mm outer dia carries steam if the heat transfer coefficient between the cylinder and the surrounding is 5 watt per meter square Kelvin. It is proposed to reduce the heat loss from the pipe by adding insulation having a thermal conductivity of 0.05 watt per meter Kelvin. Which of the following is true? Yes, quickly tell me. Again, the same concept, you have to calculate the critical radius of insulation and you have to tell me in which region your radius is lying, whether it's less than critical radius or greater than critical radius by adding the insulation. Yes, same pattern. And also please like this session and also share with your friends so that they will also be benefited from this live free series video. Okay, so you can like it, share it, and also subscribe so that you will be getting any future notification. What is the level of questions? Yes, it's basically between a level of SSC JE, 1 mark problem. What you can do, you can prepare or you can practice previous year GATE 1 mark problem for for VIZAG Steel. Okay, because the calcs are not allowed, so definitely you won't be getting that much of difficult problem, and time will be a main constraint, so you need to increase your speed. Option C. Okay, very good. All of you are correct. Option C the correct answer. Let us check. Your radius is coming out to be 12.5 mm. The radius is coming to be 12.5 mm. And RC, critical radius of insulation, is K by H. Again, the same formula. K is your 0.05 and H is 5. So it comes out to be 10 mm. Okay. Your RC comes out to be 10 mm. Now, if RC is 10 mm, already your radius is 12.5 mm. That means your graph will be somewhere around it. This is your RC. You are lying in this region number 2. Added insulation will decrease the heat transfer. So basically, adding insulation will reduce the heat loss. Option C. Mohan Maya, yes, VIZAG Steel has postponed their paper. So yes, similar pattern you can expect in SSC JE. Okay, similar pattern you can expect in SSC JE. So basically, you are preparing indirectly for SSC JE. Don't worry. Okay. Never ever. Whenever any exam is postponed or cancelled, don't worry, that preparation will be helpful for any other examination, and a series of examination is coming in line, so don't worry, just be ready for any examination you are having. Let us go for the next question. It is desired to increase the heat dissipation rate over the surface of electronic device of spherical shape. Please remember it's a spherical shape of 5 mm radius exposed to convection of 20 watt per meter square Kelvin by engaging in a spherical shell of conductivity 0.08 watt per meter Kelvin. For the maximum heat flow, the diameter of the shell to be. Yes. Quickly tell me, what should be the diameter of the shell for maximum heat flow? So basically they are asking, when your maximum heat flow is occurring, this is your curve. It is basically occurring when your radius is equal to critical radius of insulation. Yes, quickly tell me. Now we are getting a mix of answer from Jagdish and Satyakant. Okay, Satish, fine. So I'm getting mix of answers. Which answer is correct? Please tell me. Rashad is correct. Sharmila is also correct. Rahul Sharma is also correct. Very good. Rahul Sharma. What is the formula for spherical? Please remember it's a spherical surface. It's a spherical surface. So remember, whenever you are talking about critical radius of insulation for a spherical surface, the formula is RC is equal to 2 into K by H. Remember the formula? It's a spherical surface. Yes, exactly, Rashad, correct. 2K by H. Now, what is K? 2 into K. What's the value of K? 0.08. 0.08. H value is 20. So it's basically, it comes out to be 8 mm, I suppose, if I'm correct. Your RC is 8 mm. In the question, they are asking radius or diameter. Please tell me whether they are asking radius or diameter. Please check the statement of the problem. They are asking the diameter. So those students, those who have responded option D is absolutely wrong. They are asking diameter. Then your DC is equal to 16 mm. So option B is correct answer. Fine. Now, I've seen some of the students have responded D. In a hurry, students do commit a mistake. Instead of marking, they know the concept. But in a hurry, they mark the wrong option. So I deliberately taken up this question. This is very easy problem, but still students have marked option D. Is that clear? So remember, always try to read the question once, and if you feel any parameter you need to write, just write it on the paper. If they're giving a rough paper, just write it. Diameter you need to calculate. Okay, because in a hurry you might calculate radius, mark option D, and your answer is wrong. It's a very basic question. Okay. Sir, will BARC exam on Wednesday postponed? No. BARC examination is still on this scheduled time only. Fine. No postponed of the BARC examination. Yes, VIZAG still has postponed it. So don't worry about BARC. Let us go to the next problem. Now, a spherical shaped orange K is equal to 0.5 watt per meter degree Celsius having 60 mm in diameter undergoes a ripening process and generates 8000 watt per meter cube of energy. If the external temperature of the orange is 20 degrees Celsius, determine the maximum temperature at the center of the orange. Yes. Now it's a question from the heat generation topic. Please apply your concept. It's a very basic question. There's a direct formula for calculation of the maximum temperature of the body. Yes, anyone? Basically, we are having an orange, okay, whose outer or the surface temperature is 20 degrees Celsius. You need to calculate what is the maximum temperature of this body. Fine. Q dot, your heat generation is 8000 watt per meter cube. This is the heat generation or internal heat generation. Okay. Next is, let us convert this into radius. Radius is equal to 30 mm. Radius is 30 mm. And the surface temperature, let us take this as surface temperature TW is equal to 20 degrees Celsius. Now, what is the Tmax formula? I got one answer from Satyakant. Your answer is absolutely correct. Very good. Prahlad, yes, definitely, because whenever you're getting any chance for getting any sessions, definitely do attend that sessions. So what's the formula? Direct formula, your T maximum is equal to TW plus Q dot R square by 6. I suppose those who have studied three-dimensional heat conduction equation in the spherical coordinate, internal heat generation, three-dimension heat conduction. Remember, you have derived this expression. So they basically asking this direct formula. T max, TW is 20 plus Q dot is 8000 into radius is 0.03 whole square upon 6 into K value is 0.5. Try to solve it. Try to solve it. Yes, very good. Sadanand Mahato, correct. Avinash, Rakesh Mohanty, very good. Your option is correct. You will be getting approximately 22.4 degrees Celsius. So I suppose option A. Yes, option A is the correct answer. Sir, my question is for you. Heat transfer के lecture आपके series wise से मिलेंगे, देखने काफी help मिलती है हमें. Thank you for that. Just you can see my series lectures which are there in the YouTube. So don't worry. You will be definitely improving your concept, because I always tell my students, just improve your concepts and apply that concept in the questions. You can definitely will be helping out. Fine. And moreover, if you're getting any doubt, you can come to the Gradeup app. You can post your doubts. We will be available all the time. Okay. And moreover, like all of you know about coronavirus, so it's better just stay at home. Just be attended to the lectures which are happening on the online platform, and Gradeup is giving you a bunch of classes so that you can, without traveling, you will be enjoying the lectures. Okay, so very good. So let us go to the next question. For a circular tube of equal length and diameter shown below, the view factor F13 is given as 0.17. F13 is equal to 0.17. It is given. Now this is the second question, a second type of problem which is definitely being asked in SSC JE and any PSUs, because it is very easy to solve. If you know the concept, you will be definitely able to solve this. Okay, just try to solve this problem. F13 is given. They are basically asking what is the shape factor from body F221. This is surface 1. The surrounding surface, circumferential surface is surface 2, and the bottom surface is surface 3. They are asking what is F21. How to solve it? You need to apply only two theorems, that is summation rule and second is reciprocity theorem. After just apply these two concepts, you will be definitely getting the answer. So I got one answer from Nitish. Very good. Your answer is not correct, because you are calculating, I suppose you are calculating F12. Calculate F21. सर गेट केमिकल इंजीनियरिंग बार इस बार गलत हो गया, बट आपके लेक्चर से ओके फाइन. Okay, fine. Satyakant, yes, very good. Your answer is correct. Nitish Kumar, please try to, because in the question they are asking F21, not F12. Correct. Satyakant Mishra is correct. Prahlad Kishore, try to solve this. Rahul, very good. Okay, now Shubham, yes, your answer is correct. Very good. Rashad, your answer is correct. Sovik Mukherjee, very good. I think students are basically calculating F12. You will be getting F12 as 0.83. But in the problem they are asking F21. Okay. Rahul and Rahul is saying 0.83, which is F12. How to calculate? You need to use your summation rule, that is F11 plus F12 plus F13 is equal to 1. This is your summation rule. F11 is equal to 0 because it's a flat surface. F12 you need to calculate, and F13 is already given 0.17. So your F12 is equal to 0.83. If F12 is equal to 0.83, you will be using the formula reciprocity theorem. F12 into A2 is equal to F12 into A1. Fine. F21 you need to calculate into A2. What is the area 2? This is A2. So it will be pi d into D. That is pi d into length. Length is equal to D, is equal to F12 is 0.83 into A1. What is the formula of A1? It is pi r square or pi d square by 4. Fine, just solve it. D square will be cancelling out, this will be cancelling out. So it is 0.83 by 4. So this will be F21.208, I suppose. 208 or 207. So your approximate answer is option B. Very good. Avinash Bhatt, Ajay Shinde, so we correct. Rahul, yes. Now you are correct, Rahul. Very good. They are asking F21, not F12. If in the question they are asking what is the shape factor from body 1 to 2, that is F12, in that case option D is correct. But in the problem they are asking F21, so option B is correct. Let us move to the next question. Okay, if the now question from the your convection, if Prandtl number is 0.064 and coefficient friction coefficient is 0.64, what is the Stanton number? Yes, now you have to use Reynolds-Kohlenberg equation. Reynolds-Kohlenberg equation. एक बार और समझा दीजिए please. Yes, definitely. Now what is a summation rule? Summation rule is the sum of all the surface with the surrounding. So F11, F12, F13. This is your surface 1. It's a flat surface. So fraction of radiation leaving that surface and incident on the surface will be equal to 0. F12 you will be calculating. F13 is already given in the problem. This is 0.17. So F12 plus 0.17 equal to 1. So F12 is equal to 0.83. So F21 into A2 is equal to F12 into A1. What is A2? A2 will be 2 pi R into L. This is the A2. Fine. In this case, what is radius? It is equal to capital D, or you can directly write this pi into capital D. What is L? L is equal to D. So pi D, D is equal to A2. A1. A1 will be the area of this circle. Fine. A1 is the area of this circle, which is pi by 4D square. Clear? Just solve it. You will be getting the correct answer, 0.28. Let us solve this problem. You need to apply Reynolds-Kohlenberg analogy. Prandtl number is given. Prandtl number is equal to 0.064. Friction coefficient CEFX is equal to 0.64. You need to calculate what is Stanton number. Very good. I got one answer from Satyakant and he is absolutely correct. Anyone else? Option A, B, C or D? Yes, very good. Rahul is correct. Rahul Sharma, I got 2 answers. I need more answers from you guys. I'm giving you a hint. You need to apply Reynolds-Kohlenberg equation, which is Stanton number into Prandtl number power 2 by 3 is equal to CFX by 2. This is the formula. Okay. Now Stanton number you need to calculate. What is Prandtl number? This is 0.064 power 2 by 3 is equal to CFX is 0.64 by 2. What is 0.064 power 2 by 3? It is 0.4 whole square. So Stanton number is equal to 0.4 whole square is equal to 0.64 by 2. Just calculate it. You will be getting Stanton number is equal to 2. Without calculus, option C. Option C, very good. Rashad, no, you will be getting option C as the correct answer. Option C. Clear? Option C, very good. Nitish, Jagdish, Gurana, Pralad, very good. Abhinandan, after a long time, Abhinandan. Option C, yes, very good, correct. So let us move to the next problem. Now this question from the heat exchanger. It seems to be very lengthy problem, but when you read the statement, it's very, we can say it's a one-liner problem. Just read the statement. A counterflow double pipe heat exchanger using superheated steam is used to heat water at a rate of 10,500 kg per hour. The steam enters the heat exchanger at, let me help you out with drawing the diagram. Let me help you out with drawing the diagram. This is your hot fluid, this is your cold fluid. Your hot fluid is entering at 180 and leaving at 130. Your cold fluid is entering at 30 and leaving at 80. Okay, so this is your delta Ti, this is your delta To. Now what is delta Ti? Delta Ti is equal to 100 delta TO is equal to 100. What is LMTD? Yes, quickly tell me what is LMTD. It is skin coefficient. Coefficient of skin friction. Okay. Option C. Okay, very good. Correct answer. Naveen, Ganesh, very good. Now, whenever you are having this criteria, whenever you are having a condition such that your delta Ti and delta To are same, then what is LMTD? Very good, Nitish Kumar. In that case, your LMTD, which is denoted as delta Tm, will be exactly equal to any of the two temperatures, which is equal to 100 degrees Celsius. Okay, exactly, very good. All of you are correct. Avinash, Rakesh, Satyakant, Ganesh, 100 degree. Now, you can directly use the formula UA delta Tm is equal to, now they are given the mass flow rate of hot fluid, so you'll be using the hot fluid, and please convert this into your SI units. So this is m dot Cp, so this is 1050 divided by 3600 mass flow rate into Cp of water is 4187 into temperature difference, this is 180 minus 130, so it will be 50. 180 minus 130 is 50. So your delta, you need to calculate area. U value is already given, it is 814. So you'll be getting A approximately equal to 7.5. I suppose you'll be getting option C. Option C, you'll be getting option C as the correct answer, 7.5 meters square. Exactly. So whenever you are getting in counterflow these two temperature difference to be same, so directly you can say LMTD is equal to any of the temperatures. Is that clear? So option C, 7.5 meter square is the correct answer. Clear? Shall we move to the next problem? I need everyone to please share this session so that all of your friends will be benefited. Let us go to the next problem. Two long parallel surfaces, each of emissivity 0.6, are maintained at different temperatures. If it is desired to reduce 80% of this radiant heat transfer by inserting a thin parallel sheet of same emissivity on the both the side, the number of space and your surface resistance. Lucky, it's for PSU's exams. Yes, definitely it's for gate. For 1 marks gate, you can definitely go for this. But it's basically dedicated for PSUs and SSC JE. Okay? Because in SSC and PSUs, you'll be getting 1 mark problem. So these are the questions which you can expect from the heat transfer subject. Without calci, tough hoga. Yes, I've taken up that problem because that will improve or increase your calculation. This question, yes, definitely I will be explaining. Don't worry about that, Rahul. Now, they have said you need to reduce the heat transfer by 80%. I have given you a shortcut formula for this. So let us suppose we are having two plates. Inside these two plates, we are inserting some sheets. This is basically known as sheet. So whenever we are inserting the sheets having the same emissivity of that of plates, so there's a direct formula for this. The formula for this is Q with shield is equal to 1 upon n plus 1 Q without shield. Remember, those who have studied from my lectures, they might be knowing about this explanation. So why we are using shield? Shield is basically used to decrease the rate of heat transfer. Okay. Now they are asking how many number of space and surface resistance should be there. In gate 20, how many marks is required to get admission? Good. IIT. Lucky will be. We are having a session tomorrow. What should be done after gate? So definitely we'll be having a dedicated session for that. So don't worry. Tomorrow 9 o'clock we'll be having a session, post gate session. So what should be done after gate? What is the expected cutoff for different IITs? So don't worry. We are conducting this session tomorrow. Now, in order to have 80%. This should be equal to 0.2. If this is equal to 0.2, then only we'll be having 80% reduction. If this should be equal to 0.2, then n equal to 4. If n equal to 4, then only you will be getting 0.2. So you got 4 number of shields should be used. Now for what's the direct formula? Space resistance. Space resistance is equal to n plus 1, where n is number of shields, and your surface resistance is equal to 2n plus 2. Just place the value of n equal to 4, it will be 5 and 10. So option A is the correct answer. And also without solving, you can definitely solve this problem. How? Because always remember, your surface resistance will be always greater than space resistance. So directly this option and this option will be cancelled out. So directly without solving, you can definitely solve this problem. So option A is the correct answer. Okay. Let us move to the next problem. Again from your shape factor. A solid sphere, surface 1, of radius r is placed inside a hollow hemisphere, surface 2, having radius 4r. The shape factor f21. Quickly. Ek bar or please explain which one? This one? It's very easy. Just very easy. Just try to read the previous lectures. You will be definitely helping out. Always remember, shielding is used to reduce the rate of heat transfer. So from that concept, we are using that formula. Now coming back to this problem, they are asking what is the shape factor from F2 to 1. Quickly solve it. There is a sphere. Okay, a sphere is kept inside a hemispherical, hollow hemispheric. Fine, like this. So you need to tell me what is F21. F21. Okay. I got one answer from Rashad, and your answer, please check your answer. Please check your answer, Rashad. Anyone else who has solved it? Lucky is correct. Satyakant, Mishra and Lucky, both of you are correct. How to solve it? Tell me, first of all, tell me what will be F11. Quickly tell me what will be F11. Satyakant is correct. What will be F11? That means the fraction of radiation which is leaving the surface and reaching its own surface for surface 1. Tell me, what is the value of F11? Is it equal to 1 or 0? Exactly, Dikshant. Very good. It is definitely equal to 0. So if this is equal to 0, we can directly write F11 plus F12 is equal to 1, because there are only two surfaces in contact. So F12 is equal to 1. You need to calculate F21. Again, you need to apply reciprocity theorem. Abhinandan, correct. Your answer is correct. So F21 into A2 is equal to F12 into A1. Now F21 into A2. What is area 2? What is the surface area of hemisphere? A2 will be equal to 2 pi r square. 2 pi r square. Fine. So it will be 2 pi. What is the radius? It is 4r whole square is equal to F12 is 1. What is A1? This is a sphere. So it will be 4 pi r square. Is that clear? So most of the terms will be cancelling out. So F21 will be equal to, yes, quickly. Now there is one thing, just because this is your 2 pi r square plus, you need to take this area also. You need to take this area. This is your pi r square, which is 4r whole square. You need to take that also. If you take this 4r whole square, so this will be the total area. Fine, this will be total area. Clear? So let us change the value of A2. A2 will be F21 into your 2 pi 4r whole square plus pi 4r whole square. Now it's correct. Fine. So F21 will be 1 by 12. Just you need to take the common terms. 4 pi r square will be cancelling out. Just take the common term of 4 pi r square, that will be cancelling out. Just take this 4, you'll be getting 1 by 12. Exactly. Very good, Rahul. And please check, Dikshant, you'll be getting option A, 1 by 12. 1 by 12 is the correct answer. And please also share with your friends so that they will be benefited from these sessions. All of the friends, like for the chemical background also, for the mechanical background also, because heat transfer is a common subject for both the branches. Fine. Please, you need to take the complete, because you cannot neglect this area also. So what is this area? This is 2 pi r square, which is your 4r, plus pi r square, which is pi 4r whole square. Fine, thank you, Prahlad. So 1 by 12 is the correct answer. Option A, I suppose. Now it's correct. I suppose now you have understood how to solve the problem coming from your shape factor. Let us move to the next problem. Now this problem is from your this is from your convection topic. Yes, you need to take the total area, because some of the students in a hurry, they are not taking the base circle, because that is also one of the surface of that hemisphere. Please start the general awareness lecture also for SSC JE, because this is a weak point. Yes, definitely, because all the technical aspirants, they have a weak point of general awareness, and every day we are conducting classes for general awareness in the SSC JE channel. So you can come at the morning and the afternoon session. We like Monday to Friday we are having classes. Now talk about this. There is a flow through pipe going on. The wall temperature is maintained. Now please tell me, what is the meaning of this term? The wall temperature is maintained at, always remember, whenever we are talking about flow through pipe, there are two approaches in laminar flow. They also have they stated, no, they have not stated about laminar flow. They are talking about the laminar flow. In laminar flow, they are basically telling two approaches. That is, one is constant heat flux and second is constant wall temperature. So this is the case of constant wall temperature. Constant wall temperature case. So what is the Nusselt number for constant wall? Always remember, for constant wall, the Nusselt number is directly equal to 3.66. So it is H into LC D by K, 3.66. You need to calculate the value of H. 3.66 into K is 0.12 divided by diameter. What's the diameter of the pipe? It is 15 centimeter, that is 0.15. So you need to tell me what is the approximate value. Yes, exactly. If this would have been a constant heat flux, in that case the Nusselt number would have been 4.36. Okay, so you can expect another question like this. So this is a constant wall temperature case. So constant wall temperature case, you will be getting the Nusselt number is equal to 3.66, and this will be approximately 2.9 something, 2.9. So option A. Option A. Okay. Yes, very good. How to get a maximum in exam, solving more problems or understand problems. 2.93. How to get maximum in exam? Look, if you are talking about SSC JE or any PSU exam, you need to increase your speed, because the question difficulty is not that much high. You need to increase your speed, then only you will be able to crack it. Effect of variation of K with temperature distribution. It's basically, I have discussed this. There are three curves. Those who remember, there are basically three curves like this. Fine. Your temperature with distance x or delta. Fine. So there are three curves. One is beta greater than 1, beta less than 1. Yes, you need to assume it to be a laminar flow. Because why laminar flow? If this would have been a turbulent flow, they need to give the expression also. They need to give the empirical formulas also. Then only you will be solving the question from the turbulent flow. Okay. Now in this case, no velocity is given, and also they have stating it as fully developed flow. Wall temperature is maintained. So by default, they are talking about a laminar flow, that is constant heat condition or constant wall temperature condition. Clear? Next question. Yes, again a very basic question from your सर एक क्वेश्चन है आपसे, बाकी PSU's एग्जाम हम अपनी स्पीड कैसे बढ़ाएं? I'm not getting your correct. Okay, बाकी एग्जाम में अपनी स्पीड कैसे बढ़? Okay, fine. In that case, how to increase your, basically you're asking how to increase your speed in the PSU exam. Just you need to first of all clear your concept, apply some easy questions, and please set your clock, because time is also one of the most important factor in PSU and SSC JE examination. So don't take much of the time in solving a problem. Okay, now let us talk about this. It's a spherical shape. RC is equal to 2K by H. 2 into K value is, now there are two K values. There are two K values. Which K value you need to take? They are having two thermal conductivity. One is 300 watt per meter Kelvin. Another is 1 watt per meter Kelvin. Which we need to take? Always remember, whenever we are calculating the thermal radius of insulation or critical radius of insulation, in that case we always take the K of insulation. Okay, so we always see K of insulator. That means it is equal to 1 divided by H is 10. So this will be, I suppose, 200 mm. Okay, this is 0.2 meter, or RC is equal to 200 mm. Option B. Option B. Yes, very good, Satyakant. Option B is correct. 2K by H. Always remember, K is of the insulator. They are given two insulations to confuse you, and also if you use this 300, you won't be having any matching option. Okay. Always remember, if I write this precisely, this is K of insulator. Exactly, this is not the K of the pipe, it is K of the insulator, so it is exactly equal to 200. Insulation, yes Rashad, very good, it's of the insulator. Let us go to the next problem. It's a direct formula base. What is the heat resistance or thermal resistance equation or formula for a cylinder? Please tell me quickly. I don't want anyone to please commit a mistake in this question. It's a direct formula base. Is it option A? Is it option B? Is it option C? Or is it option D? Yes, very good all of you. Mahato, Rashad, Sadanand, Rahul Sharma, very good. Lucky, option A is correct, because what is the formula for a cylinder? For a cylinder, your thermal resistance RTH, it is equal to ln R2 by R1 upon 2 pi KL. This was the case. This is a pipe having a length L. It is a hollow pipe having radius R1 and R2. We take a bigger circle. So this is R1, this is R2. Okay. So ln R2 by R1 upon 2 by KL. Option A is the correct answer. Very good. Let us move to the next question, because I don't suppose any explanation is required. It's a direct formula base. Chiranjit Karmakar, no option B. How it can be option B? This will be negative, because R1 is internal radius, R2 is external radius. If this would have been negative, then thermal resistance is negative, which is not justified. It should be a positive value. So it is ln R2 by R1. Option A. Next question. A solid cylinder is located at the center of hollow sphere. Okay, so we are having a hollow sphere, and it is at the center of the hollow sphere we are having a cylinder. The cylinder is surface 2 and hollow sphere is surface 1. The diameter of this sphere is, that is your D1 is equal to 1 meter, and the cylinder diameter and length both are, that is D2 is equal to L is equal to 0.5 meter. You have to tell me what is F11. F11 you need to calculate. You need to calculate F11. Yes, please share this session, because I need everyone to, most of your friends to be looking this video and improving their heat transfer concept questions. Okay. So I got one answer from Avinash and Tirumalai. Very good. .375. Okay, let us check it whether the answer is correct or not. I have given you the diagram, I have given you the radius, the diameter, the length. You have to tell me what is F11. For F11, you need to get the value of F12. What is F21? First of all, tell me what is the value of F21. Is it equal to 1? Is it equal to 0? Is it equal to less than 1 or greater than 1? Yes. F21. Please look at this diagram. What will be F21? That means the radiation which is leaving surface 2 and reaching surface 1. So always it will be equal to 1, because what is F? This will be always be equal to 1. Is that clear? Why? Because F22 will always be equal to 0. Because if I talk about this surface, this is a complete cylinder, always there will not be any radiation which will be reaching its own surface. Okay. So your F22 is equal to 0, that means F21 equal to 1. So you can calculate F12 into A1 is equal to F21 into A2. Now what is A2? A2 is the complete area of this. Okay, A2 is complete area of this surface. Tell me what will be A2? If I remove this, now A2 will be equal to this area, and the center area. So this will be pi r square plus 2 pi r into L, if this is equal to L, let us suppose, plus pi r square. So these are the three areas. So you can directly write this is equal to 2 pi r square plus 2 pi r into L. Clear? Instead of this, what you can write? Now what is the radius? Radius is equal to 0.5 by 2. R2 is equal to 0.5 by 2. Okay. So you can directly write 0.5 by 2. So this will be 2 into. Instead of radius, what you can write? You can express in terms of diameter. So this will be pi d square by 4. 2 will be cancelled, plus pi d L. Why I am writing in terms of d and L? Why? Because the diameter and length of the cylinder are same. Fine. So this is and let us take it is equal to d. Fine. So this will be, now you can direct, this is 1, this is pi d square by 2, plus instead of L I can directly write equal to d. So this is pi d square, because d2 is equal to L. Fine. Now what is A1? A1 is the complete, this is sphere, so A1 is equal to 4 pi r square. Fine. So this is pi d square. This is pi d, capital D, the capital diameter. The diameter of this sphere is 1 meter. So instead of that I can write pi into 1 square into F12. Fine. So from this you can get the value of F12. So F12 is equal to 3 by 2 d2 square. 3 by 2 d2 square. Okay, fine. Now next is F21. If I remove this, you need to calculate F11. So F11 plus F12 is equal to 1. Fine. So F11 is equal to 1 minus 3 by 2. D2 is 0.5 whole square. So we'll be getting, I suppose, 0.625. So option B. Option B. Yes, very good. Option B is the correct answer. You'll be getting 0.625. You'll be getting 0.625. Option B is the correct answer. Very good. 5 by 8. Very good. It is approximately equal to 5 by 8. So Rashad, Sadanand, Satya, Kant Mishra, all of you are correct. So we'll be getting F11 as 0.625. Let us move to the next question quickly. There are infinitely long cylinders having diameter ratio d2 by d1. What is the shape factor of the outer cylinder with itself? That means, let us suppose I am taking the side view. This is your, take it as d1. Fine. So this is surface 1, this is surface 2. So they will be asking what is the value of F22. What is the value of F22? Quickly solve with this problem. What is the value of F22? So very basic. Always, that is why I am saying in every session, always try to gain the knowledge, try to get the knowledge and try to apply that concept in the questions. Then only you will be able to solve or crack any examination. Okay. Now I've got one answer. He is absolutely correct. Nitish, your answer is correct. Lucky, please check your answer. whether it equal to 1 or it is 0.8. Please check it. Definitely it won't be equal to 1, because if I talk about f22, that means the surface, the radiation which is leaving surface 2, some of the surface will be hitting surface 1. Okay, so it should be less than 1. So very basic thing. f12 is equal to 1. The surface which is leaving surface 1, definitely all the surface will be reaching surface 2. So f12 equal to 1. So you can directly write f21 is equal to f12 into a1 by a2. Okay, this is 1. This is your its cylinder. So this will be pi d1 into L upon pi d2 into L. This will be cancelled. So this is d1 by d2, which is 1 by 5. So f21 is 1 by 5, which is and you need to calculate f22. So f22 is equal to 1 minus f21, which is 4 by 5.8. Option B. Yes, very good. 0.8 is the correct answer. Jitu, correct. Rashad, Satyakant, Avinash, very good. All of you are correct. Shemu, Pralad, please check your answer. Devjyoti Roy, very good. Option B is the correct answer. 0.8. Let us solve it. Please solve it. I want everyone to please solve it quickly so that we can solve more number of problems. Next question. Again from the convection topic. Now basically they are asking, what is the relation between the thermal boundary layer and the hydrodynamic boundary layer? Prandtl number value is given. Prandtl number is equal to 0.7. So you have to tell me which of the boundary layer is having higher thickness or whether they are equal. So I'm getting one answer from Dikshant. Very good. Pralad, your answer is correct. Quickly solve it. What's the ratio? What's the formula? Delta, the boundary layer thickness of hydrodynamic boundary layer, this is HBL, hydrodynamic boundary layer thickness, to the thermal boundary layer thickness is equal to Prandtl to the power 1 by 3. Now, if Prandtl is less than 1, in that case, what should be the case? If Prandtl is less than 1, that means delta HBL is equal to delta TBL into Prandtl number, which is less than 1. So which of the thickness will be higher? Option B or C? Definitely it won't be A, it won't be D. Tell me it's option B or C. Yes, Kalyani, no, it won't be A. Prandtl number equal to 1, then only both the boundary layers thickness are same. Option C, very good. Exactly, option C, because this is less than 1. If this is less than 1, definitely your delta HBL will be less than delta TBL. Or we can say delta is less than delta T. Also we are denoting the TBL as delta T. So option C is the correct answer. Very good. Johnson, Satyakant, Shemu, very good. Lucky, correct. Very good, all of you. Your answer is correct. Okay, let us move to the last problem of the day. A fluid having a Prandtl number unity. Now Prandtl number is given as 1. Tell me if the Prandtl number equal to 1, what is the relation between hydrodynamic boundary layer and thermal boundary layer? Just please quickly tell me, if Prandtl number equal to 1, then the relation between hydrodynamic boundary layer and thermal boundary layer, whether they are equal or unequal. Just give me that, whether they are equal or unequal. Equal, very good. Let us proceed to this problem. Flowing over a flat plate, Reynolds number is given as 4,50,000, Nusselt number is 900. You have to tell me what is the surface friction. Again, yes, very good, all of you. Those who are responding equal, very good. You need to calculate CFX. Again, your Reynolds Colenburn analogy. So it will be CFX by 2 is equal to Stanton number into Prandtl number power 2 by 3. Prandtl number equal to 1. You need to calculate SFX by 2. What is Stanton number? Tell me what is Stanton number. What is the formula of Stanton number? It is the ratio of Nusselt number by Peclet number. What is Peclet number? It's a product of Reynolds number and your Prandtl number. So you can directly write this is Nusselt number upon Reynolds number into Prandtl number into Prandtl power 2 by 3. So Nusselt number is given as 4,50,000. Nusselt number is 900 by 4,50,000 into 1 CFX by 2. Solve it and tell me what is the correct answer. Is it option A, B, C or D? Very good. Nitish correct. Altaf Hussain correct. Satyakant is correct. You'll be getting CFX equal to 0.004. So option B. Yes, option B is the correct answer. Rashad, no, option B. You'll be getting option B. Yes, Lucky correct. Sadanand Mahato correct. Abhinandan, very good. Syed, no, you won't be getting option A. Syed Akhtar, just check it. The Stanton number is the ratio of Nusselt number by Peclet, or we can say is the ratio of Nusselt number by Prandtl into Reynolds number. Okay. Yes. You're getting 0.04 or 0.004. It's 4,50,000. Clear? Got it? Jitu? Option B, I suppose. आप वीक में डेली आते हैं क्लास? Yes, definitely I'm coming every day. I'm coming every day. Please discuss about dimensionless number. Yes, definitely I've taken many classes on dimensionless number. You can definitely see my previous lectures on the Gradeup platform. Okay, so it's a complete playlist. You can definitely have a complete list of lectures we have taken for the previous heat transfer, and now also at 9 o'clock we are having the sessions going on of theory of machines. So I've taken 3 to 4 lectures, 4 classes for that. You can come join me to the 9 o'clock session. Okay, fine. So thank you guys. This was it. Yes, definitely. You need to get to the formulas. Okay, if you know the formulas, just when you are solving problem, then only you will be able to visualize, or you will be able to recall the formulas. Okay. Is it important for exam? Yes, it is important for exam. It's not like this topic is not important. Everything is important for the examination, because heat transfer is as such is a very good topic and scoring subject. So I want everyone to score 100% in heat transfer in any examination. Should it be your VIZAG or BARC or GATE, any examination. Okay. So this was it from my side. So this is about the green card. So I tell all of my students every time, just always need to practice a lot of questions, then only you will be able to grasp the concept. So this is a one-stop solution for you guys. So this is a green card for you. It's a complete 1 year. You can purchase for a 1 year, or you can go for a monthly card. So basically we'll be having subject test, mock test, and topic wise test also. It's there in this card. So you can definitely have this. So this is it. So definitely just always try to share this session, try to like this session, and try to subscribe, so that whenever we are coming live with this videos, you are benefited. So thank you guys. You were an awesome audience. So we'll meet at 9 o'clock today, the theory of machine topic. So I'm taking their velocity analysis. So we'll be having a discussion on that. Okay. Thank you guys. It was awesome with you. Heat transfer, how much weightage in VIZAG? Yes, you can expect a good amount of questions. Precisely from your critical radial thickness, shape factor. These two topics are the favorite one if I talk about the VIZAG steel. Okay, so I've taken up a good number of questions in this session. So I hope so you all have understood and applied the concept. Thank you guys. So this was it from my side. Prep smart, score better, go Gradeup. Thank you guys and all the best. Bye-bye.